Welcome geometry students to class today, or welcome geometry students to this homework help video, page 430. Let's go ahead and get started with the problems, and let's start off with numbers 1 through, let me turn over in my book here. Let's start off with numbers 1 through 8. 1 through 8 are all dealing with the same figure, okay? So, in the figure at the right, this figure here, name two triangles that are similar to MKJ. Now, I think the safest thing to do, students, is this. I think we should pause, and I think we should draw these triangles individually. And if you'll trust your teacher, you're going to see why this is a good idea to do, okay? Alright, I'm going to pull this triangle over here. This is going to take about 2 minutes, but we're going to save this and keep it so we have this for the rest of the problems, okay? So J, L, K, alright? And now let's copy our little triangle here. And we'll pull this right here, I guess. Maybe right up here. And we'll label that L, M, K. Of course, there's a right angle here. Right here. There's a right angle here, which puts one right here. And then let's copy the big triangle right here. And we'll pull that down here, okay? And of course, we'll label this J, M, K. Alright, now, students, what we need to do, please listen to me, if we're going to be using this figure right here for the next 8 problems, I think it'd be very helpful if we could kind of get some similarity statements drawn up and use those throughout these problems. I think that'd be a wise, smart thing to do, okay? So, watch carefully what I'm going to do. This angle here, J, is this angle right here, which is the exact same angle as this one here. So if I put one mark here, then I'm going to put one mark here, okay? Now see this top angle M right here, this angle here, I'm going to put 2 marks on it. 1, 2. Well, that is the exact same angle as this here. But notice it's also the exact same angle here. Okay? Now I'll put a right angle here. Okay? Now, look, there's only one angle left here that's not marked. So here's one mark, right angle. So this angle here has to get 2 marks, okay? And notice there's only one angle that's not been marked yet in this triangle. We have the right angle, the 2 marks. So this has to be the 1 mark, okay? So do you see how helpful it is to take these triangles, pull them out? We talked about this yesterday in our notes, how difficult it is to write the similarity statements. So be very careful when you're marking these angles congruent. Now that I've done that, let's write our statement, okay? Here it is. We can say triangle. We'll start with this one first, and it does not matter what order you go in. I'm going to say J, L, M, okay, is similar to triangle. Now what I put first, J has 1 mark, so K has 1 mark. K comes first. My second letter was L. L's a right angle, so here L's a right angle. My last letter's M. It has 2 marks. M has 2 marks. No, I'm sorry, that's not correct. I said JLM, and this should be, sorry students, this should be JLK. This should be a K right here. Okay, so K has 2 marks, and M has 2 marks up here. Okay, so similar to. Now, K's first here. K has 1 mark. So what angle has 1 mark down here? J. Next is L. L's the right angle. So down here the right angle is K. My last letter is M. M has 2 marks. The angle down here with 2 marks is M. So what I've done there, students, is I've drawn a similarity statement that's really, really, really going to be helpful later, okay? Now I'm going to try to copy this real quick if I can, and then move it up a little bit, okay? There, I've copied it. Now we'll slide it up. Then we're going to slide this down to give us a little more room. And I told you this would take about 2 minutes. And there we go. So now, in the figure at the right, now look carefully, they want us to name 2 triangles that are similar to MKJ. Well, here's MKJ right here, correct? See that? MKJ. So name 2 triangles similar to MKJ. Well, M 30 statement is so helpful. Now, some of you might be saying, Mr. Earhart, how did you know these triangles were similar in the first place? Well, it was a theorem that we learned yesterday. Whenever you have the altitude drawn in a right triangle in such a way that it runs from the right angle to the opposite side, it divides the triangle up into two triangles that are similar to each other, and also they're both similar to the big triangle. So all three triangles are similar to each other. So I knew that. The only thing I had to do was get these letters in the correct order so I could then match them up with this right here, okay? So what triangles are similar to MKJ? Well, here's MKJ, so I'll put MLK and JKLJ. Alright, okay, let's take a look at the next problem here. Now, okay, numbers 2 through 7. Now what we're going to do is we're going to try to use these similar statements here to help us with these problems. And I'm going to warn you right now, these are really tough. So please watch carefully how I do this, okay? So let's take a look at number 2. We want to find the missing part here, and it's not easy. So I'm going to start with my fraction that has two knowns, JK over KL. So here's JK, do you see it? Here's JK, okay? Does JK match up with JL? Well, here's JK. Is this JL right here? No. Is this JL right here? No. So what does that tell you? That tells you this is not the JK we want to use. So look for another JK. Right here. JK. Does that line up with the JL anywhere? Yes, it does. Look way over here. Do you see that? So now you know you're dealing with the first two letters in each triangle. So we have JK over JL. So JK over JL equals, then what do they have? JM. So JK over JL equals JM here and here over JK. I'm going to go over that one more time. Let's careful. Let's do it again. Okay, I've got JK here. JK over JL equals, now if you started here and went to here, then you got to start here and go to here for the next fraction. So JK over JL equals JM. Here's JM over JK. So the answer is going to be JK, or KJ is fine too. Okay, there it is. Let's try number 3. Okay, here's the triangle that we have. Let me get rid of these dots here. I probably should have gotten rid of those right away. Alright, now watch this carefully. My known fraction is LK and LM, so look for an LK. Here's an LK here and here. Does that line up with an LM anywhere? Yep, right here. There it is. Last two letters, last two letters. So I know I'm going from this triangle to this triangle. Got it? So here we go. Watch carefully. LK over LM, LK over LM equals blank over LK. Well, here's LK. So the first two letters. So it must be JL. It must be JL. Let's go over it again. Watch. LK, LK over. Did I mess up, guys? Hold on. Oh, here it is. Okay. LK over LM equals JL over LK, which is what I have right there. That's it. That's perfect. Alright, let's take a look at the next one here. Number 4. Alright, we have KM over KL. Find a KM. Here's a KM. Here and here. KM should correspond to KL. Do you see a KL here and here? No. Do you see a KL here and here? No. So this is not the KM we're talking about. So it must be the other KM right here. Let's see. KM. We're looking for a KL. Here it is right here. Look. KL. So I know I'm going from this triangle here to this triangle here. Okay? We'll start here and we'll go to here. So here we go. KM over KL. KM over KL equals blank over JK. Well, here's JK. So it must be JM. It must be JM, okay? So I'm going to put JM here, and let's see if that works. Are you ready? KM, KM over KL. KL equals equals jm over jk. And yes, that works. That's totally perfect. Okay, so the answer would be this right here, jm. Okay, moving on to number 5. Let me pause and say this again. I'm not bragging. I'm trying to tell you guys. Do you not see how amazingly important it was to start off like this? Take this big triangle, break it down to little triangles, and then write your similar statement. That's so helpful. Okay, number 5, we have ml over mk. Let's find an ml. Okay, here's an ml right here. Does that match up with an mk? Well, this is not mk, but this is right here, so we're good. Okay, so ml mk. Alright, so ml over mk equals kl over jk. So it's got to be jk. Let's do it again, okay? ml over km equals kl over jk. Alright, let's try number 6. Number 6. Alright, let's see what we got here. Okay, lm over lk. So here's lm. Does that match up with the last 2 letters here? No. Here, yes it does, look. lm over lk. So this is my first triangle. This will be my second triangle. So I go lm over lk equals blank over kj, kj. That's mk, mk. Or km. Okay, so let's take a look at it. Here we go. lm. So lm over lk equals mk over kj. Works perfectly. And then lastly, number 7. kj. Let's find us a kj. Here's a kj. Alright. Now what's supposed to go with kj? kl. So here's kj. Is this a kl? No. Is this a kl? No. So it must be a different kj. Here's a kj right here. First 2 letters. Let's see if the first 2 letters are kl. Yep, right here they are. There we go. So jk over kl. So this is my first triangle. This is my second triangle. Here we go. kj over kl equals blank over ml, ml. That's mk or km, mk or km. There it is. Alright. So here we go. Let's go over it again. kj over kl equals mk over ml. And that's it. Guys, I'm just telling you, that's how you do this, okay? You gotta work. Watch the homework videos, listen, and take really good notes. This is gonna be difficult stuff, okay? Alright, number 8, and to figure out the right width segment length is the geometric mean of ml and mj. Okay, well, here's ml, and here's mj. This right here. Now, we had a theorem that stated this. The leg of this right triangle is the geometric mean of this segment here and the segment of the entire hypotenuse. So, which segment length is the geometric mean of ml and mj, the whole hypotenuse? This segment right here, mk. The answer is mk. You gotta know that, guys, okay? You gotta know that. Memorize these. Number 9, state a reason for each step of the proof. Alright, well, let's take a look at this. S and Q are right angles. S and Q are right angles. Well, that's your given. S and Q are right angles. S and Q are right angles. That's your given. So we're going to say that's given. Alright, next, triangle PQR and RSP are right triangles. Now, how do we know that? Well, think about it. We were told in our given that angle S is a what? Right angle. And angle Q is a what? Right angle. So if I know this triangle has a right angle and this triangle has a right angle, then I can definitely state that they're right triangles. And the reason would be simple. Definition of right triangles. The definition of a right triangle is a triangle with one right angle. And we just stated up here that angle S is a right angle and angle Q is a right angle. Now, PS is congruent to QR. Okay, now look down here. Alright, look up here. PS is congruent to QR. That's your given. That's right here in your given. So that's another part of your given, alright? So, given. You guys are used to putting all your given on the first line, and that's usually how I do it too. But you can put your given wherever you want to, it's fine. PR is congruent to PR. Well, guys, we know that. That's reflexive. That's reflexive. PR is congruent to PR. Now, how can I state that these two triangles are not similar, but congruent? How can I state that they're congruent? Well, look what you've stated so far, guys. You stated that we have right triangles, okay? So we know we have right triangles. Now remember, when you have a right triangle, all that you need to prove that the two triangles are congruent is hypotenuse leg. The hypotenuse and legs of one triangle are congruent to the hypotenuse and legs of another triangle. Okay, so with that in mind, look what I've stated here. I've stated that PS is congruent to QR. Okay, that was given to me. So I know this side here is congruent to this side over here. 2 marks. 2 marks. I know this side's congruent to itself. So look what I've got in this right triangle here. I've got a hypotenuse and a leg congruent to the hypotenuse and leg over here in this right triangle. So how can I state that these two right triangles are congruent? The hypotenuse leg theorem. Okay, listen, we learned this quite a while ago. When you're referring to right triangles, okay, if the hypotenuse and leg of one right triangle is congruent to the hypotenuse leg of another right triangle, then the two triangles are congruent. They are congruent, okay? Alright, continuing on, number 10. Alright, the directions for 10 through 15, it says to find the geometric mean of the two numbers, simplify each radical, okay? Now, we've not spent a lot of time doing any simplification. However, we can look at that a little bit now at this time. Okay, students, in order to find the geometric mean of two numbers, I've taught you two different ways to do it. This is not the way we're going to do it, but I'll remind you quickly. You can put one number up here, the other number down here, put an x here, put an x here, cross multiply and solve. X times x is x squared. 9 times 41 is 369. Okay, take the square root of both sides, and you're going to get the square root of 369. Now, if you type that into your calculator, you're going to get this right here, 19.21. And if you broke this down into perfect squares, you would have 9 times 41. We know the square root of 9, cross it off, the square root of 9 is 3. So you're left with 3 square root of 41. Now sometimes you can take this radicand, which the 41 is called the radicand. You can take the radicand and break it down further. However, 41 is a prime number, nothing goes into it, so you cannot break it down any further. Now how we're going to do the rest of these, we're not going to use this method here, it's too long. We're just going to take the square root of the two numbers multiplied together. That's the best way to do it, okay? So let's find the geometric mean between these two numbers here. So the geometric mean is the square root of 4 times 100, which would be the square root of 400. Now this should come out to a perfect square. The square root of 400 is simply 20. So there's no need to simplify this or anything like that. It comes out to a perfect whole number. The square root of 400 is 20. Okay, let's take a look now at number 12. Let's find the geometric mean of 3 and 48. So the square root of 3 times 48, which would be, let's see, 24, carry your 2, 144. So 3 times 48 is 144. The square root of 144 is simply 12, not the square root of 12. Let's go back a number. The square root of 400 is not the square root of 20. It's just 20. A lot of students, for some reason, do that, okay? They think the square root of 144 is the square root of 12. The square root of 144 is just 12, because 12 times 12 is 144. All right, let's take a look at number 13. We have 11 times 121, okay? The square root of 11 times 121. Now, that one, I'm going to do this in my head. 121. I'm getting 1,331. But let me very quickly check that, make sure that's right. Yes, that is correct. Now we're going to take the square root of that, and if you do that correctly, you will get 36.48. So if you type that into your calculator, that's what you'll get. No, that's not called simplifying. That's called solving it. You solve the square root, okay? To simplify the square root, you want to break this number down into perfect squares. Well, 121 is a perfect square. We already know that, and we know that 121 goes into 1,331 11 times, okay? So, I can write 11 times 121, which is the same thing as 1,331. And now I know the square root of 121. The square root of 121 is 11. So put 11 on the outside, and this is your simplified answer. So this is your solved answer. This is your simplified answer. They're both the same, okay? I cannot take this any further because there are no perfect squares. A perfect square, by the way, is a number that you can take the square root of, like 4, 9, 16, 25, 36, 49, 64, 81, 100. Those are all perfect squares because you can take the square root of them. So, you know you're finished when no perfect squares will go into this radicand, and there are no perfect squares that go into this radicand evenly, so you're finished. Okay, let's go on to number 14. Let's find the geometric mean of these two numbers here. Okay, let me grab my calculator. 11 times 1584 is going to give you 17,424. Now let me say this to you right now. I will not give you one this big on a test or a quiz and ask you to do what to it. Simplify. That's just a waste of time, and there's no need to do that. However, you can solve this. Take your calculator and type in the square root of 17,424, and it actually comes out to a perfect square. Believe it or not, you get exactly 132. So what does that tell you? That tells you 132 times 132 equals 17,424. Okay, pretty cool. Alright, moving on to number 15. Alright, let's find the geometric mean of these two numbers. We're going to take the square root of 5 times 4,500. So let's try to do this here in our head quickly. It'd be 0, 0, 25, carry your 2, 22,500, okay? So if you take 5 times 4,500, you're going to get 22,500. Now, I guess we could quickly solve it, and when I say solve it, we can take the square root of this and see what we get. So with your calculator, take the square root of 22,500, and you get, well, look at that, it's a perfect square again, guys. 150 is your answer. So that means 150 times 150 equals 22,500, okay? So, this is your answer. That's a perfect square. There's the answer, okay? Alright, so there we're just reviewing how to find the geometric mean of a bunch of numbers. Alright, moving on to numbers 16 through 21. We're going to use the figure at the right to find the indicated length. So here we go. Are you ready? If I go too fast, just pause the video. Here we go. PM is 16, so I'm going to put a 16 right here in this line. PN is 12, so this line right here is 12, and we're looking to find PO. Now, here's what we learned. Are you ready? This is your geometric mean right here. Now, we learned that this altitude here is the geometric mean of these two numbers here. So I'm going to put my 16 here and my x down here, okay? And your geometric mean will go here and here, okay? So there we go. Your geometric mean is always written twice, diagonal from each other, and the two numbers that you're finding the geometric mean of, they always go diagonal from each other. So here we go. 16 times x would be 16x. 12 times 12 is 144. Now if you take 144 and divide it by 16, which is what you need to do, you will get 9. 16 goes into 144 9 times. So the answer is 9. Alright, let's try another one, number 18. Let's see what they give us, and then see which theorem we're going to use. PO is 7, so I'll put a 7 right here. Actually, I went the wrong way, sorry. 17's over here. MN is 20, so I'll put a 20 here. MO is 25, and that's the whole length all the way across. Okay, whole length all the way across. And MP is my question mark right there. Now, you've got to always ask yourself this question: which one of these three numbers, or three terms, is the actual geometric mean? Well, this number is, remember, we learned that the leg of a right triangle is the geometric mean of the adjacent side on the hypotenuse and the entire hypotenuse. That's one of the theorems we learned yesterday. I kind of paraphrased it, but that's what we learned yesterday. So, you've got to learn this, guys. You've got to remember which sides are your geometric means and which two numbers you're taking the geometric means of, okay? So 20 is your geometric mean. These are the two numbers here that you're taking the geometric mean of. So your x goes here and your 25 goes here, and then you write your geometric mean here and here. And here we go. 25 times x is 25x. 20 times 20 is 400. Divide both sides by 25, and x equals 8. Okay, so the answer up here should be 8. Did I do that wrong? Oh, my fault. Sorry, guys. That's right. 25 would go into 400 16 times, not 8. Try to do it too fast in my head there. 16. 25 goes into 2400. 25 goes into 400 16 times. So the answer is 16. Alright, let's continue on. Alright, on to number 18. We have PO is 7. PM is 25. Find PN. Here's your X right here. Well, guys, we learned that this altitude here, this altitude right here, is the geometric mean of these two segments here. This segment here and this segment here. So really, we're just finding the geometric mean of these two numbers. Well, isn't that what we did right back here? You were given two numbers, a number 13, and you found the geometric mean by multiplying them and taking the square root of them. So it's the same thing here. I want to find the geometric mean of these two numbers. So the square root of 25 times 7, which of course would be 175. Okay, now you can type that into your calculator and get out a decimal if you want to, or you can simplify it. I have no problem with a decimal whatsoever. So if you type this into your calculator, you will get out approximately 13.23. Okay, alright, moving on to number 19. Okay, number 19, PO is 15, so we'll put a 15 right here. Change color, see if they show up a little better. There we go. PO is 15. ON is 32. And we're going to find MO, which is the whole length of the hypotenuse all the way across. There we go. Okay, now here's what we've learned. This number here, 32, is the geometric mean of this number here and this expression here. Okay, so if I'm solving for x, then what I'm going to do is I'm going to put my two numbers that I'm finding the geometric mean of are x and 15. So x goes here, 15 goes here. Then my geometric mean, which is 32, gets written twice, here and here. So here we go. 15 times x is 15x. 32 times 32 is going to give you 1024. And then divide both sides by 15, and you're going to get 68.266666, so 68.27. And they're leaving there as a fraction, which is fine. I'm going to put 68.27. That's rounded, of course. Okay. Alright, moving on. Number 20. Okay, we have PN is 18. So this altitude going up and down is 18. PM is 24. And they want us to find the length of PO. Well, what we've learned is this altitude here, 18, is the geometric mean of these two numbers, or these two terms right here, okay? So these are the two numbers here, or the two terms, that I'm finding the geometric mean of. So my 24 goes here, equal sign, and my x goes down here. You write your geometric mean twice. So 18 here and 18 here. 24 times x is 24x. And of course 18 times 18 would be 324. Now we're going to divide both sides by 24 to get x by itself. And if you do that correctly, you're going to get 13.5 or 13.5. Or 27 over 2, whatever the back of the book has. Okay, 13.5, there we go. Alright, moving on to the last one, number 21. Number 21, here we go. Okay, mn is 40. So mn is 40. mp is 32. So this is 32. And then mo, question mark. So x all the way from here all the way to here. Okay, so with that in mind, remember we learned this, that this number here is the geometric mean of these two numbers here, this segment here, and the entire hypotenuse all the way across. So the geometric mean of 32 and x is 40 and 40. Okay, so there we go. Well, 32 times x is 32x. 40 times 40 would be 1600. Okay, now in order to get x by itself, we're going to take 1600 and divide it by 32. Okay, and you're going to get 50 exactly. So the length of x, the length of the hypotenuse, would be 50. Alright, and there we go, 50. Okay, alright, let's continue on because I hope you're getting these. Let's take a look at number 22. The altitude of a right triangle divides the hypotenuse into two segments whose lengths are 9 and 16. Find the lengths of the two legs. Alright, let's quickly get a picture of this. So here's my right triangle right here. There's my right triangle. Draw your altitude down. There's my right angle right there. And let's see. An altitude is drawn that divides the hypotenuse into two segments, 9 and 16. Well, I could put 9 here and 16 here, but it's obvious. This segment over here is longer, so I'll put 16 here and 19 here, or 9, excuse me. Okay, now here's what they want us to find. They want us to find the length of the two legs. We're going to call this leg x. We're going to call this leg y. Now, before we get into this, let me show you something. If this segment from here to here is 16, and if this segment from here to here is 9, then this segment all the way across is going to be 25. Okay? Now, we learned something, guys. Let's start with x. We learned that this segment here is the geometric mean of this segment here and the entire hypotenuse, which is this here. So if I want to find this length here, then I'm going to find the geometric mean of 16 and 25. So x equals the geometric mean of 16 times 25. Okay? And 16 times 25 is 400. And the square root of 400 is 20. So there we go. X equals 20. Okay? Now, let's go ahead and find the length of segment or side y over here. Okay? Side y. Now look. We learned, guys, that this leg right here, the length of it is the geometric mean of this segment here that's adjacent to it, plus the whole hypotenuse, which is this here. So the length of y is the geometric mean of 9 and 25. So y equals the geometric mean of 9 and 25. Okay, so y would equal the square root of 225. Now, I believe the square root of 225 is going to be perfect, a whole number, perfect square. 15 times 15 is 225. So the square root of 225 is 15. So y equals 15. Okay, a triangle drawn here. Here it is. And that is a really poor right triangle. Let's try that again. And failure again. And there we go. Now, here's my right angle. I'm going to go ahead and draw my altitude here. There we go. Put a right angle here. And now let's see what it says, okay? Each leg of the right triangle is 12 inches long, okay? So, I didn't draw this to scale very well, but here's a leg. We're going to call this 12. Here's a leg. We're going to call this 12. And the entire length of the whole hypotenuse is 12 square root of 2, okay? From here all the way down to here. Alright, now, how long is the altitude from the right angle to the hypotenuse? Well, guys, here's the altitude from the right angle to the hypotenuse. So they want us to find that length. Now, I hope that I don't do this a long way when it can be done a faster way. But the only thing that pops into my mind is this, and see if this makes sense. If I just knew that this number here, let's pretend this number here was 8, just for the fun of it, and let's pretend this length there was 4. Then I can find the altitude really easily. Remember, guys, this altitude is the geometric mean of these two numbers here. So if I want to find the altitude, then I better find these two lengths here, because once I find these two lengths here, this length here, and this length here, once I find those two lengths, then I can very easily find the altitude. So let's go over here. Remember this, right here, 12. 12 could be looked at as my geometric mean, okay? So 12 is a geometric mean of this segment here. We'll call it x. And the entire segment here, which is this. Let's go over that again. This leg right here is the geometric mean of this segment here and the entire hypotenuse. So 12 is my geometric mean. That's what I'm going to write twice. So 12 goes here and 12 goes here. My two numbers that I'm finding the geometric mean of, I'll put an x here. So it'd be x and 12 square root of 2. Alright, so x times 12 square root of 2 would be 12 square root of 2x. And 12 times 12 is 144. Alright, there we go. Now, this looks a little confusing, but it's really not too bad. We have 12 times the square root of 2 times x. Got it? So here's what I'm going to do. I'm going to divide both sides by 12 to get rid of this 12. So if I divide this side by the 12 over here, I'm left with square root of 2x equals 12. Because I divided this side by 12, and those two 12s canceled. Divide this side by 12, and we're left with 12. Okay? Now, next I can divide by the square root of 2. So x equals 12 divided by the square root of 2. Okay? Now the best way to take care of that would be to use a calculator. So I'm going to quickly type in 12 divided by square root of 2, and I'm going to get 8.48. I'm going to go and put 8.5 to make this a little easier. So this length right here is going to be 8.5, okay? 8.5. Now, moving on to find this length here. And we're going to call this length right here y, okay? From here all the way to here. We're going to call that y. Now look how we're going to do this, okay? Let me erase this over here so this is gone. Okay, now look. Remember, we've learned this. This length here is the geometric mean of this number here and the entire length of the hypotenuse, okay? So this number here is, or this length here, this is the geometric mean of this and this, okay? So the two numbers that I'm taking the geometric mean of are y and 12 square root of 2. Okay? The number that is the geometric mean is 12, so I'll put a 12 here and the 12 here. Now, if you remember, that's the exact same equation I had just a second ago, okay? The exact same one, only I had an x here. So if I do all this work again, I'm going to get the same thing, which is 8.5. So this length right here is 8.5. So the length of this green segment is 8.5. The length of this black segment right here is 8.5. So I can very easily now find the altitude. Remember, this altitude right here, we're going to call it yes, this altitude A is the geometric mean of these two numbers right here. Okay, so A equals 8.5 times 8.5. Okay, 8.5 times 8.5. Well, guys, think about that. I mean, we'll go ahead and type that in, but it's obvious the answer is going to be 8.5. If you take 8.5 times 8.5, you're going to get 72.25. So your A would equal right here the square root of 72.25. But then, if you take the square root of that, watch what happens. If you take the square root of that, you're going to get 8.5, which is what you started with, okay? So there we go. 8.5. Now I think they're going to have a little different answer here. Yeah, they're going to have it in square root form, but also they have it in decimal form. 8.49 is definitely acceptable with 8.5. Guys, I hope that made sense. If not, back it up and watch it again. That's all I can say to you, okay? It's really, really important you're understanding this math. All right, number 24. In a right triangle, the product of the legs is equal to the product of the hypotenuse and the altitude to the hypotenuse. Include a figure with your plan. This is a really, 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 really challenging problem. So if you'll listen carefully, I'm going to go slow. I'm going to help you with this, and this should kind of make sense as we go along. Now, students, the first thing that I would recommend, of course, is obviously, in my opinion, it's obvious, is to get a picture of this, okay? So we have a right triangle, and the product of the legs is equal to the product of the hypotenuse and the altitude drawn to the hypotenuse. So the first thing we're going to do is get a picture of this, okay? So here's my right triangle right here. Okay? And then I'm going to draw my altitude from the right angle. So here's my altitude. Okay? Another right angle. Alright, now let's give these vertices some names. A, B, C, and let's give this endpoint right here a name. D, okay? Now look what it's saying. Please, please, let me stop. Does everything I did there make sense? I'm just getting a picture of it. Now, in a right triangle, the product, that means you're going to multiply. Got it? The product of the legs, okay? Well, here's one leg, AB. Here's the other leg, BC, okay? So the product of the legs, AB times BC, equals the product of the legs equals the product. So we're going to multiply. What are we going to multiply? The hypotenuse and the altitude. Well, the hypotenuse is AC, and the altitude is PD. Got it? Now, they're not asking us to prove this. They're asking us to write a plan to prove it. In other words, to brainstorm and show how this can be done. Well, guys, the only thing I can think of is this. I had better write my similarity statements. Let me show you what I'm thinking. If I could somehow get AB here, now watch this, okay, and a BC down here, and an AC here, and a BC here. Look, if you cross, and of course, I say AC here and BC here for that matter. The BC could be here, and the AC could be here. It doesn't matter. But if I get something like this, if I could prove this, then I could cross multiply, right? AB times BC, booyah, equals AC times BC, booyah, okay? So my goal here, somehow, is to maybe get some proportions written from a similarity statement, so that when I then cross multiply this proportion, I get this right here. So that's my plan of attack, okay? Next problem. Just kidding, guys. That's not it, okay? We got a lot more to go. Now, so here's what we're going to do. We've got to write some similarity statements, okay? So let's start with triangle A, B, D. Got it? A, B, D. Triangle A, B, D is similar to triangle, our little triangle over here, B, D, C, this triangle right here. Now, guys, I've got got to make sure I get these three letters in the right order. That's why I wrote them down here. Well, angle A here, we studied this yesterday. Now I could draw all these triangles separately. I could draw one triangle over here, another triangle here, and a big triangle here. That takes a while, okay? So I'm going to go over what I taught you yesterday, and that is, in your notes the other day, is this angle here is going to be congruent to this angle right here, okay? So if I have A first, then I'm going to put B first. Now watch this whole thing be exactly right. Watch it be B, D, C. That would be funny. So if A is first here, then B is first over here. Now your next angle is B, okay? That's this angle here, A, B, D. This little angle right here. Well, that angle there is congruent to this angle here. Trust me, okay? So if I'm going to put B here, then C has to come next. Well, the only thing I'm left with is D. So B, C, D. Okay. Now let's get our next similarity statement. Let's finish this similarity statement. That would then be similar to. Okay, here we go. Now we're dealing with the big triangle. Okay. So let's see angle. So the big triangle is A, B, C. Now if I'm going to start off with B from B, C, D, that's this triangle here, or this angle here. I already told you this angle here is congruent to this angle down here. So I'm going to start off, if I'm putting B first here, then I'm going to put A first over here. Next is C. Well, if I'm going to put C next, okay, right here, then obviously C in the big triangle right here is congruent to C in the little triangle right here. They're the same angle. They share an angle. So next here would come C, and the only thing left is B. So there, I have my similarity statements. Now that's hopefully going to help a lot. Now remember, I'm trying to somehow get, let's set this up again, okay? I want AB times BC. Okay, and I want AC times BC. So somehow, students, I've got to get AB over BC, or these two could be swapped. I want AB over AC. So is there anywhere I have AB coinciding with BC? I think I see it right here. Right here, this might work, okay? So, my plan of attack so far is to write my similarity statements. My next plan of attack is to write a proportion like this. So, I would like to have AB over BC, or I would like to have AC here and BC up here. So AB over AC, either one of those is fine. So I'm looking for AB over BC or AB over AC. Well, let's see, here it is. This might work here. This might work. Let's be careful. AB over BC. Got it. Equals. Nope, that's not going to work. Because look, if I'm going to say AB over BC, AB over BC equals, now I've got to have an AC over here somewhere. Okay? Got to have an AC over here. If I'm going to say AB over BC equals AC over BC, it's not going to work. So maybe I really don't want this BC. Maybe I want the AC here and the BC up here. Let's see. Okay, AB over AC equals, no, that's not going to work either. If I have AB corresponding with AC, AB over AC, then it's got to equal BC over BC. That's not going to work either. So we're going to have to go on to a different plan of attack. So I've got a couple more ideas. Okay, so here we go. Okay, students, I'm back. I paused the video, not because I didn't know what to do, but because I wanted to make sure I didn't keep just trying things and wasting your time. So I went back up here, and you know, Mr. Harris is known to make little mistakes. It's frustrating, but you guys probably got this way back here at the beginning, but it is what it is, okay? We're multiplying a leg times a leg. Here's an AB. Here's BC. AB, BC, your two legs. But then it says this, guys. It says the product of the hypotenuse and the altitude. Well, the hypotenuse is AC. AC. But look at the altitude, guys. It's BD, and I put BC here. It should be BD. So, like I've told you guys in your tests and quizzes, watch your little mistakes, you know, which unfortunately, I'm kind of hypocritical there. This should be times BD. So this should be a D right here. BD, okay? Now let's see what we have going on, okay? AB, look at this. AB over BD equals AC over BC. Booyah, it works, okay? Let's go over that again. AB over BD equals AC over BC. So that's my plan of attack. I'm done. So your plan of attack would be to write a similarity statement, then write a proportion, and then multiply that proportion out, and you'll get this right here. So it sounds like a really tough proof, but it really would not be that hard to do. And I do apologize again for having the wrong letter right here. Okay, moving on. 25, 26, and 27. Here we go. In exercise 25 through 27. Use the diagram below, which shows a cross-section of the roof at the right, and we don't need all that oddy. XY is 35, YZ is 20, and XC is 40.3. Okay, we're going to find YW. Now, students, look, if there's a faster way, I'd like to know what it is, but I'm going to jump down to 26, okay? I'm just telling you right now. I'm going to find the length of XW first, okay? So they want us to find the length of XW. Now remember, this number here is the geometric mean of this and the entire hypotenuse, okay? So I'm going to call this unknown right here XW, because that's what it is. It's XW, okay? So I'm going to call this unknown right here XW. So here's what I have, okay? I have XW equals, and then 40.3 down here, because remember, if you take the geometric mean of these two terms, it will equal this leg here, which is 35 and 35. So very quickly, we're going to multiply 35 times 35, and we're going to multiply 40.3 times XW, okay? 35 times 35 is going to be 1,225. And 40.3 times XW would be 40.3 XW. Divide both sides by 40.3, and you're going to get 30.39. I'm going to go ahead and put 30.4. Okay, so there's the answer, 30.4. So I'm going to take my eraser here, erase that XW, and I'm going to write 30.4 right here. Now let's find WC. Remember, this number here is the geometric mean of this length here and the entire length all the way across, okay? So 20 is the geometric mean of those two terms. So here we go. We're going to call this unknown here WC. So I'm taking the geometric mean of WC and 40.3. And when I take the geometric mean of those two terms, I should get 20. So a 20 goes here and a 20 goes here. 20 times 20 is 400. 40.3 times WC is 40.3 WC. Now we're going to divide both sides, or multiply, or divide both sides by 40.3, and we'll get 9.925. So I'm going to call that 9.9. Okay, so I'm going to go ahead and write right here for WC. I'm going to go ahead and write 9.9. And I feel like it's important to get those numbers onto the triangle, and here's why. Now go back to 25. They want us to find the length of YW right here. YW, right? Well, remember, this length here is the geometric mean of this segment and this segment. So if I want to find YW, it's the geometric mean of 30.4 times 9.9, okay? So if I multiply 30.4 times 9.9, I'm going to get 300.96. The square root of 300.96. Now if I take the square root of that, I'm going to get 17.3481. I'm just going to leave that 17.3. They put 17.4, which is fine. I'm going to leave mine 17.3. Okay, so there we go, guys. I mean, not super hard. Just again, review these two theorems that we learned dealing with geometric means and legs and altitudes and hypotenuses, if there is such a word. Okay, moving on to 32. obviously solve for x, but let me make sure before I start solving these the wrong way. Okay, the directions say to solve for x. Okay, so now here we go again, guys. This length here, this is the geometric mean of these two numbers here. So I'm going to take the geometric mean of 3 and 12, and when I do that, it should equal x plus 4 and x plus 4. Okay, now we're going to get to some quadratics here, which is kind of, you know, a lot of algebra 2, a little bit of algebra 1, so hopefully I can help you with this, okay? Here we go. X plus 4 times x plus 4 was, first of all, let's do the easy stuff first. 3 times 12 is 36, got it? Now, you students that have only had algebra 1, please watch carefully. I'm taking x plus 4 times x plus 4. So remember how to do that from algebra 1. It's a binomial times a binomial. You take this x, multiply it times x, and multiply it times 4. X times x is x squared. X times 4 is 4x. Now take this 4 and multiply it through. 4 times x is 4x. 4 times 4 is 16. Now combine like terms, and we have x squared plus 8x plus 16. Got it? So 3 times 12 is 36. X plus 4 times x plus 4 is x squared plus 8x plus 16. Now students, I know it's been a while since algebra, but I hope you remember what to do. In algebra 1 and algebra 2, you have learned how to solve quadratic equations. And this is a quadratic equation because we have an x squared. You learned 2 or 3 different ways to do it. Hopefully you learned how to factor. You should have learned how to factor, guys, and solve equations in algebra 1 and algebra 2, or use the quadratic formula. Okay, so here we go. You never want to use the quadratic formula or factor unless one side's equal to 0. So bring your 36 over and make it negative. So bring this over, it's a negative 36, and you're left with 0 equals x squared. In fact, some of you that have had algebra 1 and algebra 2, but maybe you were in track 2 the past 2 years, really pay attention to this. Miss Calvert, of course, is an amazing teacher, but still, I'm not sure how far you guys got into this, okay? So there we go. Now, we're going to factor this to get our answer. Got it? We're going to factor this to get our answer. So here we go. You say to yourself, self, what two numbers multiplied together give me negative 20, but when added together give me positive 8? Well, I can only think of a couple numbers, only one set of numbers, and that's going to be a positive 10 and a negative 2. If you multiply those, you will get a negative 20. If you combine those, you'll get a positive 8. So we factor this quadratic trinomial by putting parentheses like this, and we put x plus 10x minus 2. Got it? Now, what you do next is you take each group and set each group equal to 0. So your first group is x plus 10. You set it equal to 0. Your next group is x minus 2, and you set it equal to 0. Bring the 10 over and make it negative. X equals negative 10. So it looks like we have 2 answers to this problem. Bring the 2 over and make it positive. X equals 2. So we have 2 answers, but maybe not. Let's come up here and let's use something that's not used very often in most people's lives. Let's use common sense, okay? Now, if you're telling me x is negative 10, if I put negative 10 in for x right here, what's negative 10 plus 4? Negative 6. So how in the world can the length of a side of a triangle be negative 6? Now listen to me carefully. I don't care if x is negative. X can be negative, that's fine. Like if this would have been negative 2. A negative 2 plus 4 is 2. So your whole length is 2, that's fine. I don't care if x is negative. But what I don't want is this length here to be negative. So if I put negative 10 in for x, I end up with getting negative 6 for my whole length, because negative 10 plus 4 is negative 6. So this cannot work. This answer right here cannot work. But 2 works just fine if you put a 2 in for x. 2 plus 4 is 6. So this whole length right here is 6. There, we did it. But they want us to solve for x. So here's your real answer right here. X equals 2. That was a pretty tough problem. Let's try another one, okay? Alright, looks like we're going to have the same problem again. which is actually pretty good because you guys can practice this, okay? So this is good for you. We'll get a lot of practice on these, okay? We know this length here is the geometric mean of this segment and this segment, okay? So if you take the geometric mean of 8 and 18, you will get x plus 9. X plus 9. Okay, let's cross multiply. 8 times 18 is going to give you 144. And x plus 9 times x plus 9. Now, we're going to do some more of these in numbers 34 and 35. This will be the last time that I come down here and do this for you, okay? In the other ones, I'm just going to write down what the product would be. Because I can tell you right now, just doing this in my head, it's going to be x squared plus 18x plus 81, okay? But I'm going to show you how I get that. And then from now on, I'm not. Remember, you take your x and multiply it through. X times x is x squared. X times 9 is 9x. Then take your 9 and multiply it through. 9 times x is 9x. 9 times 9 is 81. Combine your like terms, and you get this right here. Now remember, you never want to use the quadratic formula or factor without one side being equal to 0. So I'm going to bring the 144 over and make it negative and combine that with the 81. Okay? Now, when you do that, you're going to have a positive 81 and a negative 144. And so when you subtract those, you're going to get a negative 63. Negative 63. Now, I'm not sure if we can factor this or not, but if we can, I'm saying to myself, okay, self, what two numbers multiplied together are going to give me a negative 63, but when combined or added together are going to give me a negative or a positive 18. This one's going to be tough, guys. I'm trying to think this through here and see what I can come up with. I think I got it. 3 times 21. Yeah. A positive 21 and a negative 3. If you take a positive 21 and negative 3 and multiply them, you get a negative 63. If you combine those two numbers and add them together, you get 18. So the factorization would be x plus 21, x minus 3. Okay? Now take each group and set each group equal to 0. X plus 21 equals 0. Bring the 21 over, make it negative. X equals negative 21. X minus 3 equals 0. Bring the 3 over, make it positive. X equals 3. Now let's use common sense, okay? If you put a negative 21 in for x right here, that's okay. I don't mind x being negative, but negative 21 plus 9 is negative 12. And that means this whole length right here is a negative 12. And that's impossible to have a negative length, okay? So, the other answer we have is x equals 3, and that works fine, guys. 3 plus 9 is 12, so that's fine. So x equals 3. Okay, let's do 2 more of these, okay? Now we're dealing with this segment here, which is the geometric mean of this number, and this number here, this segment, and the whole segment across, okay? So, with that in mind, here we go. If I take the geometric mean of 16 and 9, I should get x minus 4, x minus 4, okay? Now, if I take x minus 4 times x minus 4, like I told you guys, I'm not going to work those out for you anymore. You can kind of do that on your own. Well, let's take 16 times 9 first. 16 times 9 is 144. And then x minus 4 times x minus 4 is going to be x squared minus 8x plus 16. Okay, there we go. Now, you never want to factor or use the quadratic formula unless one side is equal to 0. So we're going to bring this over and make it a negative 144. So 0 equals x squared minus 8x. Then we have a negative 144 plus 16. That's going to give us a negative 128. Now these are really getting harder and harder. I'm going to pause the video for a second and do these off to the side to save you guys time and try to figure out what two numbers, when multiplied together, give you 128, when added together, give you negative 8. Okay, students, I'm back, and to be honest with you, I wish I could give you some great secret. You just got to try different numbers. I divided 4 into it, and 6, and 8, and 2, and I finally come up with this right here. 8 and 16. I said a positive 8 times a negative 16 does give you negative 128, and if you combine these two numbers, add them together, together, you'll get a -8. So there's the factorization for you. And again, there's really no secret except trying different numbers over and over until you get them, okay? So there we go. Now, if you take this first group here and set it equal to 0, x plus 8 equals 0, bring the 8 over and make it negative, x equals -8. Well, students, that's not going to work, okay? There's no way that's going to work. If you put a -8 right here, -8 plus 4 is -12, so that's not going to work. Okay, if we take x minus 16 and set that equal to 0 and solve, bring the 16 over and make it positive. Let's see if that works. Put a 16 in for x right here. 16 minus 4 is 12, so the whole length is 12. Yes, that works. So x equals 16. Alright, moving on to number 35, okay? This length here is the geometric mean of this number here, and the whole length here, which is 48, okay? So with that in mind, if I take the geometric mean of 3 and 48, I will get out x plus 7. So here we go. If we multiply 3 times 48, we're going to get 144 again, like we've got a lot these times. And if we multiply x plus 7 times x plus 7, we're going to get x squared plus 14x plus 49, okay? Let's bring the 144 over and make it a -144. And if we do that correctly, we're going to be left with x squared plus 14x minus, let's see, it would be 95, I believe, maybe. I think that's right. Let's see. Yes, -95. Alright. So, what two numbers multiply together give me 95? When add together give me 14. Well, I'm thinking 5, maybe. Yeah, 5 times 19, that's it. So there we go. So, this will be negative and this will be positive. A -5 times a positive 19 is a -95. And if you add these two numbers together, you'll get a positive 14. So the factorization would be x minus 5x plus 19. Take your first group, set it equal to 0 and solve, and you'll get 5. That works just fine if you put a 5 right here. 5 plus 7 is 12, so the whole length is 12, okay? Take the other group, set it equal to 0 and solve. X plus 19 equals 0. Bring the 19 over and make it negative. X equals -19. There's no way that works. If you put a -19 here, the whole length is -12. So the answer is 5. Wow, these have been really, really tough. Okay, let's finish up 36 through 43 by doing, by simplifying the directions, say, to simplify the expression. So what you're looking for, students, are perfect squares that go into these numbers. Perfect squares are 2 times 2, 3 times 3, 4 times 4, 5 times 5, 6 times 6, 7 times 7, 8 times 8, 9 times 9, 10 times 10, etc., etc. So if any of those numbers will go into the radicand evenly, then I can simplify it, okay? So I think right away 4 goes into 40, so I'm going to rewrite 40 as 4 times 10. 4 times 10. Now I know the square root of 4, so cross off the 4, put a 2 on the outside, so I'm left with 2 square root of 10. Now, are there any perfect squares over here that go into 10 evenly? No, there's not, so you're finished. 2 square root of 10. Alright, let's take a look at number 37. Alright, square root of 50. Well, I'm looking for perfect squares that go into 50. 25 does. 25 goes into 50 evenly. So I'm going to write, instead of writing 50, I'm going to write 25 times 2, because 25 times 2 is 50. Now, which one of these numbers do I know the square root of? 25. So cross it off and put a 5 out here, because the square root of 25 is 5. So I'm left with 5 square root of 2. Now, do any of these perfect squares go into 2 evenly? Not at all. They're all too big. So there's your answer. Alright, moving on to 39. Now be careful on this one. The first thing I times 4 is 16. 16 plus 16 is 32. Now, do you see any numbers over here that will go into 32 evenly? Well, 4 does. So I'm going to write 4 times 8. Okay? Cross off the 4. The square root of 4 is 2. Put a 2 on the outside. Now, are there any perfect squares that go into 8 evenly? Yeah, 4 does again. So I'm going to write 2. And for 8, I'm going to put 4 times 2. Cross off the 4. The square root of 4 is 2. Put a 2 on the outside. These two numbers here get multiplied. So you're left with 4 square root of 2. Now, a lot of you might have done this. A lot of you might have said, hold it, Mr. Earhart. Instead of using 4, I'm going to use 16 because 16 goes into 32. No problem. You get the exact same answer. 32 is 16 times 2. Which one of these two numbers do you know the square root of? This one here. The square root of 16 is 4. So you're left over with 4 square root of 2. Now you can see when you use the bigger number over here, it's faster. We got the same answer, but it's faster. Okay? It's just like reducing a fraction. If I have 100 over 200, I could reduce that by 2, and by 2, and by 2 again and again. Or I could reduce both these numbers by 100 and be done with it. And the reduction of this fraction is 1/2, okay? It's the same thing here. So quite often it helps to use the biggest number if you want to save time. Alright, number 39, we have 49, 7 squared, plus 24 times 24, 576, okay? So when you add those two numbers together, you're going to get 625. Now I'm going to tell you something, guys. That's going to take a little bit of work here. This might be a perfect square. I'm going to see if it is. If it's a perfect square, we're done. Yes, it is. Good deal. So the square root of 25 is just 25. Please don't put the square root of 25, students, okay? Look, 25 times 25 equals 625. So the square root of 625 is 25. Mr. Earhart, how did you know that? I wasn't sure. So I typed into my calculator the square root of 625 and out popped this right here. So I knew I was finished, okay? Alright, moving on to number 40. Alright. We have square root of 5 squared. Now, that means square root of 5 times square root of 5, correct? I mean, 3 squared means what? 3 times 3. It means you write the 3 2 times. So square root of 5 squared means square root of 5 times square root of 5. Well, square root of 5 times square root of 5 would be square root of what? 25. 5 times 5, right? Whenever you multiply radicals, you multiply the outside numbers times the outside numbers, and there are no outside numbers. There's an imaginary 1 here, an imaginary 1. So if you want to say 1 times 1 is 1, that's fine. And then you multiply inside numbers times inside numbers. 5 times 5 is 25. So the square root of 25 is 5. You're done. Okay, number 41. Alright, same thing. We have 2 square root of 3 times 2 square root of 3. Multiply outside number times outside number. That's 4. Multiply radicand times radicand. That's 9. Now, you have 4 times the square root of 9. 4 square root of 9 means 4 times the square root of 9. Well, guys, what is the square root of 9? I mean, 9 is a perfect square. The square root of 9 is 3, is it not? Because 3 times 3 is 9. So the square root of 9 is 3. So you really have 4 times 3. So your answer would be 12, okay? And I've not been uncovering this. We've gone along, have we? Guess I better uncover these so you see we're getting the right answer. So, the answer to this would be 12, okay? Alright, moving on to number 42. Now, this one here is a little interesting. First of all, let's start with the square root of 12 up top here, okay? Square root of 12 can be broken down to the square root of 4 times 3. Let me pause and say this. A lot of you want to cross off the 2 and put a 1, and cross off the 12 and put a 6. Here's why you cannot do that. I call this number here an outside number. In other words, it's not under a radical like that, okay? This is an outside number. This is an inside number. you can only reduce inside numbers with inside numbers and outside numbers with outside numbers. Okay, so here we go. 12 is 4 times 3. Cross off 4. Square root of 4 is 2. So we put a 2 out here. So we have 2 square root of 3 over 2. Now we have an outside number and an outside number, so we can reduce. 2 goes into 2 once. 2 goes into 2 once. So you're left over with 1 square root of 3 over 1, which is the same thing as square root of 3. Okay, I've gone kind of fast. Let me get a drink of water here. Y'all look that over and see what you think, okay? Not too difficult, not too bad. Alright, moving on to number 43. Number 43. Okay, now remember what I just taught you guys. You can reduce inside numbers with inside numbers, okay? So 6 goes into both these numbers. So this becomes a 1, and this becomes a 4. So now you have the square root of what? 4 over the square root of what? 1. Do you see that? Look at it again. This is an inside number. It's under a radical. This is an inside number. It's under a radical. So 6 goes into both of those numbers. 6 goes into 6 once. 6 goes into 24 4 times. So I have this. Now we're really done. The square root of 4 is a whole number. 4 is a perfect square. The square root of 4 is 2. The square root of 1 is 1. And 2 over 1 is 2. So the answer is 2. Alright. Alright, moving on to number 44. Number 44. Okay, number 44 reads as follows. A rectangular piece of paper is folded along RT. Now, it is very important they told you it's a rectangular sheet of paper. If it's rectangular, that means you have a right angle right here. Don't forget that, okay? Alright. If ST is 3 inches, what is the length of RS in inches down here? Now, guys, look. To me, it's so common sense. I mean, it's like the replacement here. This is 3. So if from here to here is 3, then this has to be 3 also. So the answer, just using common sense, has to be 3. But I want to take it just a step further, and guys, don't say, oh, Mr. Earhart, you're being long and boring. I'll be really quick. But using geometry, watch this. I'm going to draw this line back. And I'm going to draw this line back here. Now the length from here to here is 3. And when I folded it down, ST is now here. See, ST is here. When I folded it down, ST is here. So this is a length of 3. Now if this is a right angle here, then this is a right angle here. And this length up here is 3 also. Now, remember this is a right angle because we have a rectangular sheet of paper. This is a right angle here. So all that I want to show you guys is we have a parallelogram. Okay, this is 90 here. Okay, we know we have 90 here, 90 here. This angle here has got to be 90. We folded it down to here. This is 90. So we have a parallelogram, and then parallelograms, opposite sides are equal. So we have a square is what we have. So that's one way to look at it, okay? That's a pretty simple problem. Now, number 45. This one's a little more difficult, so please pay attention, okay? D right here is 2, 2. F is 8, 2. Now here's what they want. They want us to find the coordinates of E. The coordinates of E. Now, up here they tell us DE equals EF, okay? So this equals this. Got it? Now, if that's the case, which it is, if DE equals EF and EG equals DF also, which I really don't care a whole lot about that right now. I want to show you that DE equals EF, okay? Well, remember we learned that in a triangle, this big triangle right here, if two sides are congruent, their opposite angles are congruent, okay? So that means this side is congruent to this side. This angle here is congruent to this angle. And this is a right angle. And this is a right angle. Guys, look what I got. I got angle, angle, side, congruent to angle, angle, side, angle, angle, side. Well, big deal, Mr. Earhart. Well, guys, that is a big deal. That means these two triangles are congruent. And if this triangle here is congruent to this triangle here, that means all of its parts are congruent. And if all of its parts are congruent, that means this side here is congruent to this side here. Now that's important. So D is 2, 2, okay? And F is 8, 2. Now I'd like you to use common sense, students, please. Watch this, okay? So we're over 1, 2, 1, 2, 2, 2. And this point is where in the number line 8. So what's the distance across from 2 to 8? 6. So if these two segments are equal, that means G is right in the middle. So if G is right in the middle, how far over is G? 3. So 1, 2, 3. So G's ordered pair right here. You're at 2. Go over 3. 1, 2, 3. This ordered pair right here, G, is going to be 5, comma, 2. So now we know that G is over 5 up 2. Okay? Now students, please listen. If this point is over how far? If G is over how far? 5. Then how far over is E? E is also over 5. It has to be. They're right above each other. They're vertical, okay? So if G is 5, comma 2, that means G is over 5. Then how far over is E? 5. Now all we have to do is find out how far up it is. Well, I can do that. Look at this. EG equals DF. Here's EG right here. Here's DF right here. They're equal. How far across is DF? 6. So if this is 6, then how far up is, and how did I know it was 6? I counted. This point here was at 2, and it went over to 8. So from 2 to 8 is 6. So if DF has a length of 6, then EG has a length of 6. So starting here at 2, starting at 2 on the y-axis, if I go up 6, that's going to be what? 8. If I start at 2, which is where this point is, over 5, up 2. So I'm starting at 2. If I go up 6, it's going to be at 8. So the ordered pair for E is going to be 5, 8. That's a really good question, guys. It really is. Okay? Alright, I hope that helped.